Hey, let's get going. Welcome back, Steve. Just to get you caught up, I thought we'd discuss some of the better performing notebooks slash results that people had shared on the feedback competition. I think we did, some of us did okay on the competition. Jack made submission, flying did as well. And I ended up with another bronze, but still in the 100 and something odd, 130s or something. And so we thought we'd spend some time this week looking at a couple, or how much ever people have had the chance to look at or get into details of some of the notebooks and or approaches that have been shared. So that's kind of what we are doing, but at the same time, towards the end of the meeting, let's also discuss which of the pending or what future competitions to participate in as we move forward.
Okay, congratulations there. How did you do, Jack?
Yeah, so I think I was like about halfway up the leaderboard in the end.
Right. How many people were in the competition?
I think it was like 1,800, 900, something like that.
Yeah, right now it says 1557, Steve.
All right.
Okay.
Okay, so I spent some time looking at two particular posts and or notebooks that were shared, so I can kind of share what I learned, and I still have some questions on those notebooks, and then we can go around and do the same with any notebooks that Jack or Mike had a chance to spend time with. Let me, excuse me, let me share my notebook or share my screen, and let me know if you can see my screen.
Yep,
we can see it.
Okay, so the first one that I shared, because I kind of ended up using one of his earlier notebooks, was this one by Lex Tumoro, I guess is the way to pronounce it. I'm not absolutely sure, but he does a good job of laying out the steps he has taken from about where he has a notebook. There is another notebook that he has posted where he shows with a Deberta V3 large, he has taken the results of the competition to about a score of 0.624. And that's one of the notebooks that I used, or at least his training notebook was where he has the trained weights for a Deberta V3 large model ending up in 0.624 score is one of those that I used in my ensemble. But in this post, he talks about how or what were the changes he made to that notebook to take it from about a 0.624 score to a 0.588 score, which earns him the 67th place on the leaderboard. And some of these are interesting. Many of these is stuff that people would have already seen, but some of them, at least, I had not encountered. I wanted to get people's take on whether they've seen this method and if so, are they familiar and where they've used it. So as he says, he kind of lists the various steps that he took to get the results from about a 0.65 or whatever to a 0.588. And we'll go through that. He says he's reverted at some point in time during his experiments, and of course he ran many more experiments than just what he talks about here, but he reverted from debutta v3 large to debutta large because I think of shortage of compute in training debutta v3 large even on Colab. And we'll talk about each of these in turn. And here are some of the things he mentions using pre-trained weights. And again, I think he talks about that in case of detail. So I'll just rattle off the names and then we'll get into each of those. He uses pre-trained weights. He increases the positional embedding size. This is something I had not seen before. People do. Another technique he uses is token dropout. I still am a little bit confused about whether there is actually dropout of tokens taking place or he's just using a data collation method. We'll get into that as well. Soft pseudo labels, many people would probably be familiar with. He uses that. He adds context to the essays, and then he does, instead of a single last hidden layer, he uses min, max, mean pooling of the hidden layers, and then uses the concatenation of the tree to convert as the input to the classification head. That's again something that obviously many people will be familiar with. He also uses a by LSTM at the top of the before the classification head. He uses a by LSTM layer. This is again something that NLP folks are probably very familiar with. And then in the final step, as he says, from going from 0.5983 to 588, he kind of switched from a debutta large to a debutta X large. Kind of interesting because I had not seen a debutta X large model. I'm familiar with a V2 or V3, but apparently there is an X large model as well. Now getting into the details of the experiment, and then there is a notebook where I can show you, or we can get into even more detail than what he just states here, which is the summary. So the first one he talks about is increasing the positional embedding size, which is something, again, that I have not seen. If any of you have seen this, please chime in and talk about it, where you've seen it and what you see as the benefits and stuff. But basically, what the technique seems to be that traditionally in transformers, you do positional embeddings, and then you combine it with, the standard embeddings that you get, the embedding layer that you use for converting the vocab onto a high dimension. And here what he says is if you increase, since he increases the max length, I think 2024 or 512 or something of that nature, which you can find in his notebook, he increases the size of the positional embedding to match the size of the to the max length of the input sequence. So have any of you seen anybody do this in particular in any of the competitions or anywhere else? This was something new that I had not encountered before, that is scaling the positional embeddings to match the max length.
No, I don't really know much about this. So does it increase the number of trainable parameters in the embedding layer? Is that what you're saying?
Yeah, it would, right? Because basically what you're doing is, instead of having an embedding size, a positional embedding, which is, smaller or trained with the original size, which I assume is smaller than when you increase the max length sequence of your input sequence from 512, say 2024, then he's increasing correspondingly the size of the positional embeddings as well. Which kind of somewhat makes sense, because basically what he's doing is if you stick to the original position embedding, then the mapping of the positional embeddings to the size is balanced for the original size, but will become imbalanced, or at least the positional embedding will not be of the same dimension as your max sequence length, right? If you train with a shorter sequence length. So here he is just increasing that. And as you can see, now unfortunately he has not done an ablation with just one of them. He also uses pre-trained weights. But you can see that there is a change in the leaderboard from 6.5 to 6.2. So it does seem to give him a boost.
What's the value before he, what's the value of the position IDs?
Yeah, I have,
before the change and after the change.
We can go to the notebook. Let's see whether there is, yeah, he does. Oh, here, double size of, so he's doubling it. And here is the code. And I would assume that if you, let's say if this is 1024, then he's doubling it by 2x. I don't know off the top of my head what the original positional embedding size. I assume it would match the max sequence length, in which case I would assume that's 512.
Okay.
But I mean, it should be fairly easy to check. You're working with the notebook.
So does this in effect just sort of by increasing that value, does it allow you to like more precisely pinpoint whereabouts a particular token is in the input
That's
text?
my guess. Yes,
okay.
that was my guess at what it enables you to do. And given that you are, that at least in, you know, when you embed the discourse type into the essay, you're giving multiple CLS and end tokens. So there are multiple kind of special tokens you embed in the essay, and giving it more positional capability, I'm assuming, will enable you to locate those positions better. At least that's my guess as to why the score improves. And you can see that the max length is 1024, and he's scaling it by 2, the original by 2. Therefore, I assume that, you know, the original size is probably 512.
Right. That's interesting. Yeah.
So I thought that was an interesting technique. At least I had not seen it used so far in my. Have you seen it, Steve or Mayank?
No, I've never seen it. No.
Same here. I haven't seen it either.
Yeah, so I thought that was a little interesting tweak. Pre-trained weights, obviously we're familiar, but what is interesting is he used the weights from the last competition 7th place solution winner who trained a masked language model on the large number of essays in the feedback competition, not the current one, but the previous one. So it seems like, you know, training or using weights from a pre-trained model trained on all, or I should say, though it says trained, but it's probably fine-tuned because at the end of the day, underlying is still Liberta large or Liberta whatever. Yeah, Liberta large. So it's more of fine-tuning, as I would call it, but fine-tuning using MLM model, that is masking and then using the Liberta large model, but weights from this guy's solution. So that's another interesting tweak. And this is something that I saw in the next, I'll go in through one more solution that I spent a little time trying to understand. And even in that case, in his case, and that's a notebook from this guy Abhishek Thakur that in fact Jack, you had shared a previous revision of his, and apparently his final revision got in 14th place. Currently we are discussing something which is 67th, and you will see what the guy did to get 14th place. And he also used a mass language model pre-trained on the essays. So that seems to help. That seems to be a consistent approach that both these people took. It's interesting.
I mean, this kind of strategy is it's a quite good and convenient strategy, right? Because there are so many available models out there from the past competition and from the latest competition, and because most people use Liberta large, you could just take these weights and start from there, right?
Yeah, I thought that was fairly clever because, in fact, you could kind of stack it, because now you could use this guy's model if it's anywhere related to in the next competition that you mentioned, there'll be a third version as well.
Well, yeah, and you could use the top solutions model, right, from this competition for the next one.
Yeah, if they said the weights, though, right? I mean, you'd have to.
Yeah,
they would have to have showed it or store it as a data set or something.
Mm.
But I thought, so both these, at least I didn't have a hard time understanding. I can kind of get what they're doing and also why they are doing it. The third one, I will skip for a minute because I have some questions about it and I'll come back to it. We will not skip over it entirely, but let me get to the other ones which are fairly explainable, and then I have some questions so we can get into a discussion on the token dropout one. But let's get through the other ones. This one is again something that we would have seen, pseudo labeling. So what he does is, he uses an ensemble of models to generate pseudo labels on the prior competition, and he uses some Optuna tuning for finding the weights of how much weight to allocate to this different models on the different on the different models that he uses for ensembling.
Does any of you use Optuna? I've heard it mentioned a few times recently, and I'm just wondering.
Yeah, I've not used it in this, although I might have used it elsewhere when I was trying to learn something. I'm trying to recall where I used it, but basically it seems like it's a technique for originally a technique for the hyperparameter tuning, but what people have also now started to use it for is not just hyperparameter tuning, but like for example, finding out learning rate or different weight decay values or different other other parameters that you would put. So basically hyperparameter tuning. But then nowadays people have repurposed the Optuna tool to also figure out the weights distribution when you're using an ensemble. That part I have not used Optuna for. I've just kind of used it straightforwardly as described for finding the best hyperparameters.
Yeah,
I've used
it in the past as well for that. But I think I was just using it for random forests or something, like some type of network like that. I used it for.
Yeah, I think that's probably where I did too.
Yeah, like I think it was like in one of the competitions, one of the previous ones, where there was like just like ensembling using random forests, and somebody else had used the Optuna thing. But I found, yeah, like it was taking quite a while, and I ended up just using the hyperparameters they'd found as opposed to the ones mine was coming back with. But yeah, so I have only used it for hyperparameter search.
Yeah, but nowadays, apparently, and I haven't yet seen a notebook that does this, so I'd be interested if you find it, please post the link of using Optuna to find the weight coefficients for ensembles, which is kind of interesting. But if it is basically an optimizer to run different things and figure out the hyperparameters, then it kind of makes sense that you could repurpose it to figure out the weights, because at the end of the day, you're just running a bunch of models and figuring out what parameters to set. And in this case, it's the weight of the models that you're combining. And in order to get a better score versus you would be in the instance that Steve was talking about, just tweaking the hyperparameters to figure out what score to get for a single model. So I can kind of see how it could be repurposed, but I haven't done it myself.
Tuning the weights of an ensemble should be faster than tuning the hyperparameters for a neural network, right? Well, maybe that's not true.
Yeah, I don't know necessarily why that would be. You would have to run the model in either case, but in one case, you're probably training. In other case, you're just running the inference, so you may be right.
Okay.
You don't really train the model when you're doing Optuna with optimizing the weight distribution. You're just running inference with pre-trained models. So you may be right in that regard.
Yeah.
But it depends on, how many models, how large they are, and blah, blah, blah. So don't know whether that is universally true, but as a general rule, you're probably right because of the difference between, training a model and what that takes versus just running inference on the data with a model. And then it is,
is it meant to be
go ahead.
the latest, consider the best tool for tuning compared with older ones? Like, I don't know, is there a one called Neptune or something, or some others? I know even in 1DV, you can use this thing called a sweep to find the best set of hyperparameters. But it seems like Optuna gets mentioned a lot. So I'm just wondering if it's like considered the best tool for this at the moment.
Yeah, I've used the 1DB sweep as well. It like obviously it gives you like loads of graphical stuff as well, so you can sort of see how they all did. But I think the Optuna one is maybe more optimized and faster. I think that's maybe why people are using it. So yeah, like definitely it seems to be very popular at the minute within Kaggle competitions.
Right.
And
maybe I'll give it a
the
try.
thing he mentioned, sorry, go ahead, Jack.
No. Go
Um,
ahead.
and then he mentions that, he tried multiple rounds that didn't help, but also that the soft predictions, by that soft labels, my understanding, and I'd like comments or corrections if my understanding is incorrect. I assume what he means by soft labels is he actually is using the distribution of the actual underlying, or I should say, the predicted by the pseudo labeling of all three adequate, inadequate, and adequate, effective, and ineffective predictions, whatever their probability seems to be, versus a hard, this is just adequate and it's not, and not the other two categories. So that's what I understand soft labels versus hard labels to be. Is my understanding correct, or do you guys have a different understanding?
Yeah, I agree with you. I think with hard labels, you're just using one hot encoding, whereas with soft labels, you're using the softmax output from your neural network, your trained neural network.
Yeah, the probability distribution across the classes, right?
Yeah.
Yeah. Okay. So that's what he does on the prior, and then he uses an ensemble of previous models to get that trained. So that makes sense as well. And then this is again something that's very consistent, but it's interesting how subsequent modifications, as you will see in Abhishek's notebook, which I don't fully understand, but we'll get to that. Here, the point I wanted to make is both of them add the extra context to the essay. And the way he does this is to say, he just adds the discourse type like lead, and then where it ends, and then the type, and then the end, and that's all he does. Right? Meaning he just embeds the type of discourse, and the header, and then the end token at the end of that, and the CLS and separate tokens continue to be at the beginning and the end. But he embeds these into the essay itself, and then attaches the essay at the end. So that's something he does, which is, again, we've looked at this, but there'll be more details to come about this. And then the mean, minimum, and max pool layers. This is something, again, that we have seen in our prior competition as well. Just using
Shri,
the minimum, mean.
We cannot see your screen.
Oh, maybe I stop sharing. Yeah, I think the network dropped me for some reason. Let me know when you can see it.
Yep, we can see it now.
Yep.
Okay, so here I was saying, the extra context to essay, and he adds the lead and then just the end. And then again, the concluding statement, which is the discourse type, and then the end. And that's the nature of what he does. And I'll switch to his notebook once we're through this to also look at a little bit more detail. And then mean, min, max pool, which is concatenating the outputs to give a 3 by 1024 hidden state, and then adding a by LSTM layer. Any questions? After the backbone's final hidden state. So these are all fairly known techniques, or at least things that I've seen applied, although I haven't done all of them myself. Then, before we get into the setting for the experiments and stuff, let's talk about this one, which was a little bit of a puzzle for me. There's this thing he calls token dropout. And he says, and it'll make more sense when I switch to his actual code in a minute. He added a data collator based on the Hugging Face data collator for language modules. And here it seems all he's doing is, again, doing the same thing that you would do with a mass language model, which is replacing some characters with a mass token and other characters with a random token. So it's almost as if, but it's kind of strange that he uses the term token dropout, because basically this is almost like, even though a masked language model, it's kind of puzzling to me because underlying the whole thing is the Liberta model, which itself is, I'm assuming, and I haven't looked at it recently, so maybe I'm wrong. If any of you know off the top of my head, correct me, but I would assume the Liberta model does some kind of mass language modeling in its training. And then he uses a pre-trained token, which has been trained on the data set in question. And then he adds in his current model a data collator, which happens to throw in random mask, right? Some characters with a mask and some characters with a random token, which is where, to me at least, is fascinating that you would continue to do that throughout the pipeline, meaning multiple times in the pipeline. Does that make sense? That's what I'm saying. And if you see here, his token dropout seems to help him somewhat from 0.626 to 0.622. And something he doesn't list here, but which he does use, that's probably because in his baseline of 0.624 that he got to, he already is using, is giving topics to the essays. So now with this much of background, let's jump to his notebook. So can you guys still see my screen?
Yeah.
Okay. So, here are some parameters that he sets, loads the data. Then he does, he does the fixes that you have seen if you follow the competition on multiple, by addressing the coding and all that kind of stuff. By coding, I mean, the UTF-8 or CPF 1252 or whatever, the you encode, decode stuff. And then he uses stratified group k-fold so that the essays either are in one, all of the essay is in one batch or the other, so it doesn't split the essays, thereby having some leakage issues. Then soft pseudo labels. Then the next one he does, which is kind of interesting, I mentioned this, that he does this in his baseline 0.624 score obtaining notebook, but he does that here as well, is the topics from word topics. So, extract the topics and you use them as well. And as I've explained in prior discussions, this seems to help the model figure things out with respect to the task at hand of finding the adequate and effective distributions. So he gives different headings to the topics and combines, does that for both the current essays and the 2021 essays. And here is the next, adding the essay context thing that he does as to how he does it. So this one gives you a little bit more detail, and this is important because in Abhishek's notebook, he does it differently, and just that difference seems to, count for a lot, because this guy ended up 67th, whereas Abhishek, as you see, ended up 14th in the competition. So he does discourse type, then the topic. So discourse type, which is, the type of discourse, so that it lead and between CLS and separate tokens. Then the topic, so that's the topic, Mars space is the topic, and then there is a separation token. Then the actual text of the discourse, and that's the text, and then there's a separate. And then the essay, as I showed before when we discussed, he embeds the type of discourse when the discourse is, not when I should say, but where the discourse is part of the essay text. So he puts in a lead because it's at that's the lead, then the lead text goes here, and then there's the end, and then blah, blah, blah. And then there's a concluding statement, and then the statement itself, and then there is an end, and then finally a separator token. So this is the nature of how he builds his input sequence. Any questions about this?
From Abhishek's?
It's different because Abhishek, as I recall it, and we'll look at it when we get to Abhishek's notebook, it's different because Abhishek, as I understand it, predicts or uses these tokens differently. He encodes labels for all of these, whereas this guy doesn't do that. He just throws in the tokens, but at the end of the day, he's just interested in predicting the three classes, and doesn't, for example, doesn't use it as a span exercise or anything of that kind, whereas Abhishek seems to handle the task differently.
Okay.
And that's something I'll get into when we look at Abhishek and what he does, because here he eventually through the min, max, mean, by LSTM, and then classification, he's just using the CLS tokens to classify the output into adequate, ineffective, and effective. Whereas Abhishek seems to handle that task differently. Okay, and then fast tokenizer, blah, blah, blah. And then here is the interesting, this is the encoding, decoding part that I was talking about, UTF-8 to CP1252, blah, blah, blah. And then, just doing the essay part and generating the appropriate embedding of the tokens for the discourse type and all that. And then comes the, what he calls token dropout, but which seems to mainly be doing mass language prediction. Because so what he does, if you see, is he's used a data collator with token dropout. And by the way, that's the name he gives. He uses a mix-in, and as I understand it, basically, reading through the code, I haven't run the code myself, but it seems like all he's doing is what he described, that is, replace some tokens with a mask and some tokens with another token, and thereby, yeah, see here he has a comment, rest or 80% of the time we replace masked input tokens with tokenizer.mask token. So there is a mask token stuck in, and then 10% of the time we keep the masked input tokens unchanged. So it's as if he does masking yet again, even though the model has already been trained with this approach and fine-tuned on this particular data set.
Maybe he needs to do this because he's using a masked language model. So like he needs to also mask the inputs.
Not really, right? I mean, whenever we use debert, I mean, his underlying model is deberta, and we have used deberta models without redoing a masking.
Okay, yeah, that's true.
Do you think he's doing it because of the fact that he is using the weights from the previous competition, and this is sort of fine tuning it onto the new data?
That might be true. It's another way of generating, you're saying, a language model fine-tuned on the current essay data set.
Yeah, perhaps, yeah.
Yeah, that might be, but you could potentially just do that as a pre-training step, taking the pre-trained models, I don't know what you call it, like after pre-training training, you know, take the pre-trained models from the prior and then run it with just this step, but you could potentially combine this step with all the rest you're doing too and save yourself another run. Interesting. But the reason you give is interesting. I hadn't thought of that. But I haven't seen this either, so I thought that's an interesting strategy. That you retrain, but what you say makes sense, Steve. Then the mean min-max pooling, and then obviously pre-training, it just gets the weights. And then, you know, here is the model, blah, blah, blah. Now, one thing I didn't know, maybe I know Steve has used LSTM models before and stuff. One of the things I saw, and I couldn't quickly answer it myself, maybe it's not that big deal, but he uses the hidden size of the final hidden layer of the transformer to form the LSTM's input. But then for the next thing, which is, I think I forget what this thing is called in an LSTM, but it kind of halves the config hidden size. Any reasoning or logic or any thought as to why he would change the size, internal hidden size, or whatever this size is called of an LSTM, the second parameter in an LSTM, other than the input size? I have to go back. I mean, I looked at an LSTM. Let me know if you can see the change in my notebook thing, but you can see, let's see. Yeah, the first one is the input. Oops. Can you see my screen?
Yeah, yep.
Okay. Sorry, I think I got muted when I got dropped too. So I was asking the question of, you know, if you look at and if you see the input size to the LSTM is the first parameter, the second parameter is the hidden size in the hidden state of the LSTM. And if I go back to his notebook, he halves the hidden size in LSTM. Do you know Steve, from your use of LSTM, I was just curious why the change and why not just leave it hidden size, or is it just to reduce the parameter? Is there any downsides to doing it or any reasons to do it this way?
I can't remember, sorry, but yeah, so is that that's the information that's carried over, isn't it, between each time step?
Yeah.
Maybe it just sort of compresses the information, so I'm not sure.
Yeah, and then he uses 2 layers, and it's bidirectional. Bidirectional is true. Yeah, I just was curious about that.
Yeah, I wonder if by halving the size of the hidden size, if you've got bidirectional, do the two of them add together to make the original size again, or if having 2 layers and half of the hidden size then, or half of the input size.
Yeah, I mean, in fact, that's why I was like, is it anything related to LSTM usage that I'm not familiar with?
Yeah, I haven't used them in a while, so I can't remember.
You know, I kind of had the same inclination to think it kind of helps to do some compression type of thing instead of retaining the size to be also the same as the hidden size. Maybe it just is too big at that point, given, you know, his output will be 1024, so this makes it probably 512. But then again, I have to check whether this hidden size is 3 times that when he combines the min max, or is it just and you know, he uses the BiLSTM directly before he does the min max, I think. And then there's the dropout.
Yeah, the half size might be due to the fact that the author is using a bidirectional LSTM, so I think so if the hidden size is 256 and the hidden size would be 128, so 128 for each direction.
Yeah, that's something I'll have to check in the LSTM documentation as to whether that's the way it works. That's why I asked Steve. I haven't used LSTMs recently and or quite enough to recall that off the top of my head. But that's a good guess, Mayank. I would check that. And you know, the rest of it is the same as before. And then here is the code for doubling the size of the position embeddings. Pop it, double it, stick it back. Right, and then he uses some particular optimizer, some Adam W optimizer and that kind of stuff, and then does the training loading. Or the rest of it should be familiar, and he ends up with the 0.588 score, which is pretty darn good. And overall, I think he ended up 67. So this one, at least, the thing I liked about it, which, you know, many people just give a kind of high-level overview of what they did and wave their hands. This guy kind of calls out the techniques and then gives the code for each of the techniques, which I really like. So at least you can go in and play with it to try and get an understanding, or you can do ablations of how much does each thing help and get familiar with it. So I thought that was a nice write-up plus code, even though it may be 67, but at least it's a complete picture. Any questions or comments on this? And some new thoughts.
Is he using Transformers trainer class or his own trainer class?
I think he does his transformer training.
Okay.
Because that's at least what he used in the notebook that I, in his weights that I used and from the notebook. Here, he's using training arguments and trainer.
Okay.
And sorry, this notebook here, did he achieve that score of 588 just with this one model, as opposed to ensembling with other ones?
Oh, he ensembles. Actually, if you see, he does mention that in the here. He does all that, and then the final ensemble is this. But it's all variations of
All right. So
what he has
like
done, right?
all of those 5 ensemble bits, they've used all these techniques, and he basically just like seems to swap between extra large and large, and then with the LSTM and without it, but everything else is the same. Yep.
That's right. And this ensemble gives him that.
If you see here, like the list of ensembles, you see like say for example the first one, it says 2 folds diverta x large. It means like when he's creating the CV folds, he creates probably like 5 folds, right? And he's only using the model trained on 2 of these 5 folds, and taking the average between them. Is that what is meant here?
Okay, I'm going to guess, because there is based on what he has done elsewhere, because I did, as I mentioned, use his 0.624 results or the weights from that result. And there he uses 5 folds, and when or at least to get the result, he uses 5 folds. And when he says 2 folds, in this case, my assumption is he actually just trains 2 folds and he uses that. And in this case, it's just, a single fold rather than training 5 folds and picking the fold which gives him the best result from the 5 fold. Because the way, and again, I'm guessing it could be that he trained 5 and chose the 2 best. That's another approach. But typically what I've seen him do is combine the raw folds and then average them. So even in this case, what he would do is he would leave the scores of the 2 folds, so, there would be like 1, 2, 3, 4, 5, 6, and then 8. So he would average 8 scores for each of the 3 categories to get his final score. As to your question of whether he just uses 2 folds, at least I've seen him, if he says 5 folds, then he does the entire 5 folds and takes the 5 folds as 5 folds into the ensemble.
Okay, thanks.
But he's not very clear which of those he's doing when he says this. But, I thought it was a good notebook that explained a lot of things in detail and provided the code so you can go through it, and thought that was worth my time kind of going through it to understand, and I'd play with it some more too going forward. Okay, the one more, or if any of you have looked at any other notebooks, feel free to jump in and share, and I'll share Abhishek's once you're done. Any, Jack or Mayank, did you have a chance to look at any other notebooks that you thought were interesting and go through it and want to share any lessons learned?
I looked at the submission notebook shared by Team Hydrogen, but I mean, we kind of sort of talked about their solution last week, so I think it would be probably more interesting to hear about Abhishek's solution.
Okay, so let me switch to Abhishek's. This one, honestly, I have more questions about it. I'm not fully I don't fully understand the details. One is, of course, he uses his TES library, which from whatever little I spent, I didn't spend a whole lot of time looking at the TES library, but my preliminary understanding is it's just yet another interface like Lightning or Fast AI or something to do training quickly and vary some parameters and make it simpler to do training while interfacing with NLP tasks. But beyond that, I didn't spend a lot of time looking at the details of TES's operation. Is that roughly correct, Jack? Is TES just yet another training framework working with PyTorch, much like Thought Lightning or Fast AI or something like that?
Yeah, I think so. He basically, I guess, over the years, he's sort of just kept some, I guess, what they call boilerplate codes for deep learning, and he's just using them and developing them as he goes along.
Okay. So I didn't spend too much time on that one. So the remarkable thing about this guy, though, and this guy's model, is he achieves this score. Remember that the other guy did 0.588 or 586 with an ensemble of 8 models, right? You saw the twofold, blah, blah, blah. This guy achieves 0.577 with a single model. So I thought that was pretty impressive. And so to start off, he does the same thing I mentioned the other guy did. He trains an MLM model on the old data set, right? So again, going with what Jack said, this seems to be kind of a common technique that we should probably think about using on NLP. Is just train underlying data, whatever else on the current data with an MLM and generate a fine-tuned model or whatever with the current data. So he just says, I took all the data from previous feedback, fine-tuned the data V3 large using this. And the perplexity score was 4.5. I don't know what the, indication of goodness would be and what's goodness. I understand perplexity, but don't know how you would judge whether a score is good enough or not and stuff. He himself says he could have trained more, but didn't. So one interesting question would be, how do you know when to stop, other than you just stop when you run out of resources or when you have run out of time that you've allocated or something. But if anybody has any thoughts on what score would they use to stop, I'm all ears. Or if you find any links to notebooks that talk about this, I'll search too. I haven't looked at it. The other thing,
I guess
and now
it means
here
he
comes
wasn't
interesting.
overfitting. I think what he means is like when he stopped, he wasn't. He stopped prematurely. Like he wasn't about to overfit.
Yeah,
because normally when people stop, it's because they've started overfitting.
Yeah, but in this case, you're just training a MLM, right? Like large language model. So maybe you could train to get lower perplexity, right? Because I think lower is better, if I'm not mistaken, because you don't want to be perplexed. So the lower the score, the better. Am I right, Steve? Because this was covered in the Stanford NLP course that we did, but it's been a while, so I've forgotten. But I think from the terminology of perplexity, I would think you would want lower perplexity.
I can't remember. I know it's in that new Hugging Face book on transformers, and I remember reading it, but I've forgotten again.
Do you know off the top of your head, Mike?
Nope.
Can you guys still see my screen?
Yep.
Okay. So next is what he does with the essay text, right? And here you can see he just doesn't stick kind of the end and the discourse type. He does this. He does the CLS, some text, and then when your discourse type starts, he puts a CLS token followed, or a CLS underscore discourse type, and then an end underscore discourse type. And then further on down, he puts a separator token, right? So that, and then he arranges the data according to what he says below, which I have a question on the last two bullets. So let's take it a step at a time. So first of all, I didn't understand what he means by this. And since you've kind of fiddled around with a prior notebook of his, Jack, maybe you have some thoughts. What does he mean by convert the data to old format? Does that simply mean, kind of getting all this you encode, decode stuff taken care of, or does he mean something different that I'm missing?
I'm not sure at this point.
Yeah, I wasn't sure what this bullet meant myself, so I have some questions about that. Then this makes sense for each token, that is for each of the token that he gets by after he finishes doing this, add on a zero label for the discourse type if they are not a valid discourse. So that would mean that if the token is not between these two things, then I'm going to give it a zero label. That's my understanding. Okay, and let's keep going, and then you tell me if my understanding is doesn't make sense. Then what he does is for each token, add -100 as a label for the discourse effectiveness if they are not a valid discourse. So because we have to predict the effectiveness of each discourse type, that is, so each of these snippets would have an effectiveness label associated with it. The zero label is for tokens which are not a discourse, but the -100 is for any tokens for discourse effectiveness if they are not a valid discourse. So if it's a valid discourse, then it would have obviously a label as to whether it's effective, ineffective, or adequate. If it's not a valid discourse, then its label with respect to effectiveness will be -100 because you don't want a loss to generate any loss for these tokens. And it is zero from the perspective of the type of discourse, which is why he adds a zero on the label for the discourse type. So there are two labels, right? One is for the discourse type, which is a zero label, and then a -100 for the discourse effectiveness label. So he's, I think, doing a task of predicting two things, Jack, much like you were doing. I believe, I'm not 100% sure. Then, if the token belongs to one of the discourse CLS or end token, or it's a valid discourse, he adds the discourse type ID as their label. So that means for any, oops, what happened to my cursor? Oh, come on. Somehow I managed to freeze my mouse here, not conducive to explaining things. Can you guys still hear me?
Yeah, I can still hear you. You can still see your screen.
Yeah, I don't know. I seem to have frozen my mouse here.
Yeah, I can see your screen now.
Or my battery chose to die at an inconvenient time. Something of that nature. Dang. incredibly annoying because I can't move. Which, come on. You have to be kidding me. Okay, any ideas of how I
Is it-
get out of this?
Was it the battery in your mouse has died?
No, my mouse still seems to have. Give me a minute while I. It still seems to give me the green light that it has power from the battery. Then why does it? Oh man, come on. This is when I was about to. And the worst part is I can't even go over and click stop sharing. Okay, give me a minute while I try to maybe switch over my batteries and see whether that helps. Sorry, guys. Not what I wanted to be wasting you guys' time with, but.
By the way, I've had a look at the new competitions. Feedback 3 has been released.
I saw that.
Oh, really?
Does it follow
Yeah.
on from the? Does it follow on from the competition you've just done?
Yeah.
So
I wonder if the same.
These notebooks here. Yeah, so like they were using pre-trained weights from the last feedback competition, but like that was a year ago.
Yeah.
And then they just released feedback 2, which you've just done, and now feedback 3 has been released immediately.
Yeah.
Yeah. And is it?
I wonder if the same top competitors will participate as well.
Well, you would think like if you've just sort of come out of feedback 2 that you would have sort of all the knowledge in your head and whatever, it'd be easy to continue. Yeah, like I saw that
It's
competition
not that
just
simple,
started.
isn't it? Like, yeah, I guess, I guess we can now just kind of use feedback 1 and feedback 2's models that have been made public and then train them for feedback 3.
Yeah.
Yeah, sorry guys, I still am stuck. So maybe I'll just reboot, in which case I'll log off my notebook and one of you folks can start sharing, or we can, talk to the part about future competitions, and I'll get back to this in a subsequent, probably in the next meeting. I apologize, but seems to be stuck with no ability to fix. I don't know whether it's the computer that's the problem or just the mouse or what, but.
I think you are not sharing your screen, right? We can see the types.
I am still in the sharing mode, but my computer is kind of.
We can't see your screen anymore.
Yeah, it's kind of. So I'm going to have to log out here. I think the computer encountered some issue or something.
No issues. We can share our screen right now from our end.
Yeah, go ahead and do that. And of course, I'm completely logged out. I'm only on my phone. It'll take me a few minutes to get back. So the question then, given that competition has started, is would you folks want, is that a variation or what does that look like, Jack? What is the objective of the third phase and all that?
I don't know. I haven't looked, but I thought you wanted to do it. Like you wanted to to get the AWP working for that or something.
Yeah, well, I haven't had the chance to try that yet, and a bunch of other techniques.
Yeah, this will be your
but
chance.
What is it you want to get working? Amazon Web?
AWP.
Adversarial waste preservation.
Oh, right. Sorry. Yeah, yeah.
Yeah, I've seen from the notebooks of to stop Kagglers that the AWP edition had an effect of 0.005 or that approx points in the leaderboard. So if someone implements it, you're sure to jump by at least 0.005 points in the leaderboard.
Yeah, that's not trivial, right? I think in this competition at least, because I think, my score was 0.600. I was 148. Let's say I was 138 or some 136, but let's say around number 140. And the top of the leaderboard was 0.55 something or 0.565 or 0.555. So the difference between number 1 and number 150 is just or 140 is just 0.045. So 0.005 would still bring you up quite a bit.
Yeah, I think that's quite good.
Yeah.
I also
That
tried to
would
read.
be.
Yeah, please go ahead.
Yeah, so sorry, I'm still rebooting my computer. It may take a few more minutes before I can even log in to the stuff and bring the notebook back up again. But I was just curious what you folks wanted to do with respect to the future competition of, I'm open to, if they've already reopened to, and if it's interesting to try an NLP again, I'm also open to changing and going in the direction of one of the other competitions. I'm up for whatever seems to be the consensus opinion of what to do.
Personally, because I missed this competition, the Feedback 2 competition, yeah, I would happily do the next Feedback one. Yeah, because I've been reading my Transformers book or whatever, and so like I'd like to sort of do a Transformers competition.
Practice.
So for you guys, maybe like if you've sort of come straight out of Feedback 2, as I say, perhaps you've got all the knowledge in your head already, and so it might be easy for you to do well in the next one.
Maybe. It depends on what the task is. So can you quickly look at that and talk about the task while my notebook comes up, Jack? What seems to be the task in the Feedback 3 competition, or anybody who is connected, if they can just quickly talk to that. And how long
I'll
of a
share my
time period?
screen. I'm not a fast reader, so I just share my screen so you guys can read it.
Well, it has just started, so there's pretty much 3 months left, I think.
Ah, okay. So that's good.
Let's just look at the training.
Because in the first one, they wanted you to predict the discourse type. In the second one, they wanted you to predict the effectiveness. So what would it be in the final one?
Yeah, I think it says in the overview, Jack, of what they want to do.
Okay, yeah. Here we are.
Yeah, so
So So I guess
predict language
the inputs would
proficiency.
be, yeah. So like, I guess the inputs are essays, and you want to grade these essays. I don't think it says a lot in this first paragraph, does it? In this section.
And no, just that, as you say, it's going to take essays and predict language proficiency. But I don't know how
And
they
what is
measure
the
proficiency.
metric of language proficiency?
I think like, so each essay, and they are the output would be 1, 2, 3, 4, 5, 6 numbers between 1 and 5, and so these numbers would be, I mean, the predictions would be like the score for the cohesion of the essay, the score for the how good the syntax is of the for the essay, and so on.
Oh, so it almost seems like, yeah, so it's like assign a grade to the essay, but then the interesting thing would be what are the components of the grade, and it seems like the components could be the
cohesion, syntax,
that's an interesting part, whether it would be the effectiveness of the discourse types, or because if you have a really good so that's the interesting part. How do they, or what are they, how are they scoring? How do they expect the scoring of 1, 2, 3, 4, 5 to be, right?
Yeah. So for example, if someone uses a lot of fancy words in the essay, then the vocabulary score will be like close to 5, maybe.
Oh, so there are some groups of categories like vocabulary and,
yes,
I don't know.
Yeah.
I don't actually understand what cohesion means exactly. What's the cohesion of an essay? Or
I think it means sort of how the essay sort of hangs together, the structure of it. Like, obviously, if you just have an essay and it just jumps about talking from one thing to the next thing, they aren't connected.
Okay.
So it's like when it's like writing paragraphs, if the sentences within the paragraph connect to each other well.
Yeah, and in fact, things like, that's why I thought it was what, like things like whether it has a lead statement, whether it has a concluding statement, whether it, those kinds of things, which could be components of what has been done before.
Yeah. Man, these teachers really need a lot of help.
Sorry?
So yeah, the test set is similar, a similar size to the previous one. It's like about 3,000 essays you have to process. But there doesn't seem to be, I wonder if there's a separate, there's another efficiency prize. It's cool. Yeah, and it has a similar form as before. I guess this time they're using mean squared error rather than log loss. What does MCR mean? I don't know, some form of mean squared error. Yeah.
So the scoring is MSE based on all the categories and stuff, or?
Yeah, it's kind of like the mean squared error average over all the different properties of the essay, like the cohesion, grammar, that kind of stuff. Yeah. What other? It doesn't say how the money is split, but I don't think it matters for me really.
Yeah, we are all very worried about the money, Jack. It's because we get to glance at it from very far away.
Yeah, I mean, I guess this is the like logical choice for the next competition because, I mean, as you mentioned, you really want to get the AWP working, right? For
yeah, or at
for
least try now that we have like he's saying at least we should be a little better at doing NLP than before. But I think from what I'm hearing, it seems like the nature of the competition is also, or I should say not the nature, but what I meant by it is the prediction task has also gotten tougher. It's not that I would imagine, because ultimately what they're going after is automated grading, and which is what this would be, right? Because given an essay and you want an automatic grader tool to just grade the essays and on the basis of multiple criteria. And from what you rattled, which would be a fairly tough pieces that you have to get right to get.
Yeah. See, Wainakama has already shared some code.
Sorry?
Yes, there is quite a lot of activities already.
Oh, I see.
So,
and when did it start?
I don't know. I only saw it like before.
Have you go to the top there?
Before
It's only started a couple of days ago.
Wow.
Oh, sorry, you go to overview again? Yeah, the timeline. Yeah. 30th of August.
30th.
Oh, 2-3 days back. Wow.
Yeah.
Yeah. The good thing about doing this competition is that I noticed I read in the discussions among some top Kagglers, at the end of the last one, like for example, this guy, like so he listed these lessons learned from this one that so the competitions have gotten tougher. So you actually he suggests that we enter early so we can actually try more experiments. And I guess the drawback is that I think you mentioned somewhere that the knowledge from the previous competitions no longer carry over as nicely as in the past.
I don't know, like I think like
like
all of those
right?
all those tricks that Srinivas was showing in Notebook today. I'm sure that you could apply all of those type of tricks.
Yeah, but then like everybody is sort of on an equal footing, right?
Oh yeah, like everybody else will probably pick them up as well, or some
Yeah.
people will, or whatever.
Yeah.
But yeah.
Yeah, but I mean, ultimately, it's about us trying to get better, not
So for
less
so for
worried
example, I
about.
tried the for example, I tried the tricks that were found to be crucial in the US patent competition, but it, I mean, didn't help for this one.
Yeah.
Yeah, and as Steve was saying, I've also been attending the NLP with transformers and kind of getting familiar with a little bit more familiar with Hugging Faces interface API, if you will, and stuff. So that standpoint, it kind of would, at least I'm okay with jumping in, given that it is just started, and if it's something of interest to try out the techniques and get more familiar. And I'm sure Arto hasn't been here the last couple of weeks, but I'm sure given it's NLP, he'll probably take a crack at it too, would be my guess.
Yeah, I wonder how he's doing in the key.
Yeah, because, you guys also stuck in. Sorry, you're breaking up a little bit, Jack.
Can you hear me?
Jack, having a hard time hearing you.
So there.
Yeah, I can't hear him either. I thought it was mine.
He's kind of breaking. Jack, you still there?
Yeah, he's dropped off.
Maybe he'll rejoin.
Yeah, so I've got some time coming up, so I'm happy to do this competition if everybody else is. The fact it's just started.
Yeah.
And, so although I haven't been able to join those meetings about the Transformers book, I have been reading my book, so unfortunately it coincided with me being away. So
right, yeah, no, Mike has been joining, and I've been on some calls and trying stuff out. So I wouldn't mind getting it. I'm back, and actually from my preliminary debug, it was neither the mouse nor my computer. It is my computer, but I have a Windows PC, so I also have a virus protection tool, and that tool just manages to kick in whenever to update itself, and it did that and screwed my cost. The thing to completely hang up. So, Jack, can you say something now and see whether we can hear you better?
Hey guys, are you still there?
Yep.
Yes, now we can hear you much better. You were kind of breaking up to, or very faint or drawn out or slow or whatever.
Right. So for some reason, I kind of Zoom was playing back some of the sound bits from earlier during our meeting just now.
Oh, interesting.
Yeah.
I didn't hear that, but that's strange.
Yeah, I thought I was traveling through time, and it was very weird. Yeah, but I don't know. So so I think there's a lot of like being able to fine-tune a model well. It's not a trivial thing, I don't think. I mean, according to what he says here, and I think that's what I found for this past competition as well. It's just like
and the other thing I would comment or add on to what you said, that the thing that I found in this competition, which I found very, very interesting and fascinating, is the number of different ways. Although there are a few common ways, there is a wide variety of ways that people have gotten to good scores. And I found that very interesting because typically, at least in prior competitions that I've seen, it's like there is few techniques that people converge on and everybody kind of uses that. And that's how the top, 50 to 75 scorers all have used. But in this case, I find that there is, of course, some of the underlying models like Diberta or Diberta V3 Large or whatever, that's same. And some techniques are same, but there's still a wide variety of getting from the, say 150th point, which is kind of where I was at, to getting to the top 50. People have used a wide variety of techniques to bolster the score to get up there. And I found that very fascinating. And by the way, I'm back up so I can share my screen if people are interested and quickly go through what Abhishek has done, or do we defer it till next time? I'm okay with either.
I don't mind if
I'm all
people
right
have
with
time.
you, right? I mean, because we'll be starting the feedback 3 next week, right? So
yeah, okay. So let's go. Hopefully my computer stays up. Can you see my screen? Let me know.
Yep.
And yeah, I can scroll my mouse, as you can see. Rejoice. Okay, so let's see. This is his. So before we get into that, let's just go through this. This is where I was at. So I was saying, just to reorient us, he was kind of doing two things, right? Like for each token, add a 0 label for discourse types if they are not a valid discourse. And then for each token, add -100 as a label for discourse effectiveness if they are not a valid discourse. And then he does two things. If the token belongs to one of the CLS or N token or is a valid discourse, then he adds discourse type ID as their label. So what that means, as I understand it, is if it is within this piece here, right, then that is one of these tokens, then he adds the type ID as the label. And if the token belongs to the CLS or N or is a valid discourse, he also adds discourse effectiveness ID as the label. So that means for tokens which would fall in between here, he has two labels. One is the discourse type label and then the discourse effectiveness label. And for anything outside here, he obviously zeros them. And then for anything outside, he zeros it from a discourse type and he puts a -100 label for discourse effectiveness. And for everything inside, he puts the actual discourse type for the type label and he puts the effectiveness for the effectiveness label. So that's kind of what he says. Now, one thing which confused me between the last comment, the second last bullet and the last bullet, is he says discourse effectiveness label, which means, the one of the three labels, right? Adequate, ineffective, effective, was kept only for the CLS discourse type and N discourse type tokens. So it seems what he's saying by this is different than this bullet, because these two bullets don't quite converge or aren't consistent. What he seems to be implying, though, is that only for the CLS this discourse type and for the N discourse type token does he keep the label to be the discourse effectiveness label, not for all of the tokens in between, as he seems to say in the second last bullet.
So what's the effectiveness label for the tokens inside a discourse?
I would assume that it would probably have to be -100. That's the thing that I wasn't sure of. See, that's the thing that I wasn't clear about. Because he says discourse's effectiveness was kept only for the CLS, whereas he says here that he puts discourse effectiveness on CLS end or is a valid discourse. Now, if you drop it, then the question is, do you just not have a label, or is it, -100, or do you just not have it? That wasn't something that was clear. Unfortunately, that's an open question in my mind.
But I feel like the last bullet point kind of can be folded into the second last bullet point.
Except for this piece, right? Except for this piece, right? Because if he said that he made the token only for the discourse CLS and end, then it would be okay. But then the open question remains for the others, what would you do for discourse effectiveness?
Yeah, so if it's valid discourse, it means it's a token inside the discourse. And for that,
yes.
And
it's not a CLS or not an end.
Right. No, but like either that or a CLS or end token. If it's one of CLS start, if it's one of CLS end or discourse token, then he labels them with their effectiveness ID, right?
If it is otherwise CLS or end, and is within the discourse.
Valid discourse. Yeah.
Yeah, but then here he doesn't seem to say that he adds the effectiveness for the valid discourse, or he drops it. But does he just drop it? Does he make it -100 or what? That's what is unclear between these two bullets for me.
Oh, maybe
right.
Maybe like there's a difference between discourse effectiveness ID and discourse effectiveness label. Whereas like the label is a string, which is only kept for the CLS and end tokens. Whereas discourse effectiveness ID is 0, 1, or 2.
I'm not sure about that. Because basically he uses ID in both cases, discourse type ID or the effectiveness ID. And he's just saying that he keeps it for whatever as their label, and that label is kept only for these two and is dropped or made a -100 or what for the others. Let's assume it's dropped for now, but it's not clear, and you'd have to kind of play around with his notebook to find out. So it's not a very good, clear explanation. And then he says, so now we have for each essay input ID, input type. So and again, this is somewhat confusing for me because input ID I get, input types. So discourse type IDs, one for each input ID. But again, I'm not sure that if in an essay, you do not have the discourse. So, you have the cases where there are portions of the essay which are not discourse, then you don't have a discourse type ID for them because they don't fall within a discourse. So why does it say one for each input ID? Because, it would be 0. Well, 0 is the label, but what happens to the input type when it is not a discourse? So again, that's not very clear. So he's not explaining things as clearly as I would like, as the other guy did. So it leaves some open questions, and you'd have to probably play with his notebook to see what he's actually doing. And then, of course, the label, the actual label, most are -100. They are -100 for a discourse effectiveness. And then he repeats what he says, only start of discourse and end, which is the CLS token and the end token, have an actual label. But at the same time, he says have an actual label, but then obviously all the in this bullet, he seems to say that he has added the discourse type ID as the label for all of them. So see, that's where it's kind of not as well explained as the other guy. And then the one other trick he did, which is something very interesting, because and he attributes a lot of his benefit to this thing that he does. He says he made a crucial change in the model's embedding layer. So typically, you just like the other guy changed the size of the positional embedding. In this case, he's fiddling with the actual embedding layer of the tokens. And he says that what he does is to add another embedding layer for the discourse types and add it to the original embeddings. So he adds, like, because there are 7 discourse types, he adds 7, and actually he adds 9, which again, you have to look at why he has 9 of them, but he adds 9 additional embeddings. Now the embedding size is the same as for other tokens, but he adds 9 new embeddings to the embedding layer. And he says that that matters to the model a whole lot.
Do you know if this is different from adding a special token to the tokenizer? Because felt like I think during the US patent competition, you guys shared some code where, like, when you add special tokens to the original tokenizer, you can also resize the embedding.
Yes.
So is this
You're right.
the equivalent of that? Or?
That's a good question. I would think it is, right? What do you think, Steve?
Not sure, sorry.
Because I think from what Jack is saying, I remember also that in that case, we had to adjust the size of the embedding layer. So isn't it just a matter of adding some new tokens to, and he's just doing it differently. And in that case, also something similar was done. So at first guess, I would probably guess yes, but I would have to go back and check. But that's a good question, Jack. I hadn't thought of that similarity until you pointed it out. Because in that case also, I remember that the embedding layer was resized. And why would you resize the embedding layer if you weren't doing exactly what he's doing? Because again, here he's just doing the same thing, adding another embedding layer for the 9 new tokens. Are there any subtleties in the difference of how he's doing it versus how they did it? That's something to look into. But you're right, at a high level, it does seem like the two are different. And then here is the only other thing he says that he has done differently. He used whatever polynomial learning rate scheduler. Sorry, did you guys lose me or lose my screen?
Can still see it.
You can still see my screen, right?
Yeah.
Okay. Other than this, he used polynomial learning rate and Adam W optimizer. I mean, those are small tweaks. And then here is the thing. During inference, he just averaged the probabilities for the CLS discourse type and end discourse type tokens to get the final label. This is again something that I'd have to look at the code and run it in order to, when he says just average the probability, does it mean you just average the probability to get a single probability for any, any of the three classes, or how does that work? That's the thing that I also don't, or I haven't thought about. Any quick thoughts on that? Would it just be average the two and whatever it says? Probably because he has a label for all three, because he says it's the effectiveness label. So he has probabilities for all three possibilities. So averaging the two would mean averaging 6 is my guess. So that he eventually ends up with probability for all three classes. Does my rambling make sense that it's at the end of the day, he would still end up with probabilities for each of the three classes?
Yeah, I agree with you. So like if discourse type is, say, a lead, and so if there are, so for each lead in an essay, you would have 2 probabilities, one from the CLS and one from the end token. So if you have 2 leads, then you will have 2 CLS and 2 end token probabilities. And so you'll be averaging over 4 probabilities.
And just doing this seems to get him score of 14, but you can also see how his handling of input, I don't fully get it. I have to play with the code, but because he is see, in this case, unlike in the other case, he's actually futzing with the screwing around, to use a technical term, with the labels. He uses multiple labels, one for the discourse type and the other for the effectiveness. And I'm assuming he uses 2 labels because he's probably predicting both, although he doesn't talk about it here. And then he averages, and then he eliminates some of the ones by using -100, because in cross entropy, using -100 makes that ignore that particular label. This was something, by the way, I learned through the NLP Transformer book. That's the reason in the named entity recognition chapter of the book, they talk about putting -100 on some of the labels. And the reason is because cross entropy ignores it, if that's the case. And here is his training notebook, although it's structured weirdly because of how he does things, using tests and stuff. But here is all the training and inference code. And you'd have to run it in order to and he uses the test trainer and stuff. And I didn't have as much chance to go through his notebook to answer some of my questions, although I don't know whether it's easy, short of actually running it and looking at what he's actually doing in the code with respect to, some of the open questions we had of what does he do with the labels in between? Does he drop in? Does he do 2 sets of predictions? How does he use the labels of the discourse type ID versus the discourse effectiveness ID, blah, blah, blah. So there's a bunch of questions in this case that are open as far as I'm concerned, that I don't have a clear answer for that I can explain to people. And that leaves me a little bit dissatisfied with his explanation. Maybe he's too much of an expert for us guys. But, on the other hand, what's impressive definitely is a single model gets him 14th place in the competition. It's just a single model, of course, 5 volts. And Jack, now you can see the difference between at least what the prior guy is doing and how he uses the tags or the discourse type versus what Abhishek is doing, right? Because that guy is not doing anything with respect to averaging the CLS and end or using multiple labels or any of that kind of stuff. He's just using it as a demarcation of the different pieces embedded within the text.
Yeah, actually, they are different. They are very different approaches. This one is is to treat it as a token classification problem, whereas the previous one is just text classification. So for this one, like you actually need to make a prediction for each token and not just like the entire discourse, right? Because since he's labeling individual tokens rather than like individual discourses. I think that's like the main difference in this competition, right? That's what they found, which is to treat it as a token classification problem.
Yeah, so the token classification approach seems to get him all the way to the 14th rank.
Yeah, he has used mask language modeling in this notebook, right?
Yeah, but even the other guy used mask language modeling, right? That isn't as much because he's also, remember, as I went through, he also used mask, but I think the fundamental difference is what Jack points out, that is in that guy's case, he's just using it as a text classification, like almost like a, it's like a analogous to sentiment classification or whatever. It's a text classification. In this case, every token, that's why he assigns label to the discourse type, 0 to the non-discourse type, and then labels for the discourse effectiveness, and tries to predict the label for every token, as Jack is saying. But again, how he does that and where he drops the tokens, those details are important, and unfortunately, he does a poor job of explaining them. At least I can't understand it. Maybe if you guys can and you look at it, and feel free to chime in the next time and explain it, because I would appreciate an explanation rather than having to run through his code and multiple times and figure out what he's actually doing.
I think actually what he's doing is his model is making predictions for just the CLS and end tokens. And actually the discourse type he uses as the model input. That's why he created that extra embedding layer, right? So he's actually not doing multitasking here. Yeah, so actually he's just making predictions not on every token, but only on those CLS discourse type and end discourse type tokens. And
yeah, but then he has labels for every token, right? Like he goes through, and that's the part that I don't quite get.
Right.
If you were to ask me, okay, what's the, is it 0, is it -100, and why do we need a label for everything, and what is that? I mean, of course, if you run the code, but if I were to just explain it from his explanation, I would fail. So, for example, I'm still unclear whether he is going to put -100 for the non CLS and N token within a discourse, or 0, or what?
Yeah, I think so. The training target is the effectiveness ID, and for every token, he labels it -100, except for those CLS discourse type and N discourse type tokens. For those, he labels them either 0, I guess, for adequate, 1 for effective, and 2 for ineffective. And he needs, and with regard to discourse type, he needs to label every token because he's using that as the input. I think that's what he's doing. I wonder why he doesn't use the tokens inside the discourse. I mean, I wonder why he doesn't also make predictions for the tokens inside the discourse, like what they do in the top solution. You think like doing that would make it even better?
Yeah, so this one, I'll need to run his notebook. Assuming what you're saying, Jack, then I think it kind of makes sense. I would still like to run it to confirm my understanding, and I kind of get that clear in my head. At least the other guys, what he's doing is very clear to me. In this case, I think given what you explained, it makes sense that that's what he would be doing. I just would like to run the notebook to confirm that. But as I said, very impressive that just with that approach, he's able to get all the way up to the 14th position with just 5, single model 5 folds. No ensembling. Well, I mean, ensemble of one model is 5 folds, but that's nothing. Pretty impressive.
Yeah. It's a nice solution just to, yeah.
Right, so those were the 2 I went through just so I could kind of, because some of the others, they mention stuff, but they don't have the code and they don't go through the steps. So it's kind of like, well, I'm maybe too dumb or too kind of element or too complex for me. I mean, conceptually, you can say something and I can maybe claim to understand it, but I won't really understand it unless there is some code and there is some way that I can, that you take me through it step by step. But these 2 notebooks, I felt, for explanation, at least were a large part of the way there. So hopefully that was helpful, or at least interesting.
Yeah, thanks.
Yeah, looks like got lots of good techniques.
Yeah, and you know, I'm still on the hunt for it. An example of AWP implementation for this particular problem. So if you know or seen anything for this particular case and a simple explanation where the guy takes you through it, let me know. That'd be helpful.
Did you look at the solutions from sort of the winning solutions? Do you know, did they use AWP? Even if they didn't?
Yeah, these are from the winning. There is, by the way, since you weren't here, let me point you to maybe this one. Here is a link to all of the top ones. Steve.
Right.
The same guy that I took you through. His own solution is 67th, but that's this. He says 69, but it says 67 here. But this guy has a list of all of them. I did not go through many of these top ones because they don't, as I said, they, other than this is Abhishek's one, but many of the other ones otherwise kind of just wave their hands and give you the high level overview, but not the detail. These 2 had code and took you through, and maybe some of these bottom ones, I didn't look at them either, but these were the 2 that I found the time to do. But here is a list of all the top ones.
Just one question, did Abhishek do any pseudo labeling at all?
I didn't see anything. Of course, he
That's
did
impressive.
remember at the beginning, he said he did the pre-training using a mass language model, which the other guy also did. So, but no, he
Yeah,
didn't
but
use
he did.
topics and he didn't do any pseudo labeling either.
Right. Okay. It's interesting.
So in fact, the other thing is, if you added those two in, would you see a boost? Right, if you threw in topic, but I don't know how you would throw in a topic within an S. You would have to slide it in and make it 0 in any case, right? Because if you're doing a token classification, then bringing in a topic may not help.
No, I mean, like with Team Hydrogen, they pseudo label the effectiveness, right? But I think
Yeah, no,
according
the
to you,
pseudo labeling,
Abhishek
yes.
never
I was
did
thinking
that.
topic. Yeah, no,
So,
pseudo labeling, yes. It
that's
would be
fine.
interesting if we added the 2021 data and did a pseudo labeling. That would be interesting to combine with this and how much boost he sees from that.
Yeah, I think you would have improved it. Yeah, yeah, definitely.
So there are many more techniques discussed in this list, Steve, than what I went through.
Right. Yeah, no, I was just wondering if sort of in their high level discussions of how they did their solutions, did they use AWP?
Yes, some of them mentioned it. I did see it multiple places.
Right.
I don't remember which one of these now, but I saw it at least in 2 that I recall.
Mayank, didn't you mention that you saw some examples?
Mine?
Yeah, I thought like Mayank had mentioned that he saw some
Yeah, he did.
AWP examples.
Do you know off the top of your head which ones or have a link, Mike?
Yeah, the second solution used AWP. The one that came second one. And the third also used AWP, but there is no code for this. They are just
There isn't a code.
The second, the third.
Here. Can you guys see my screen now?
Yeah.
Yep.
Okay, so here you see here. In fact, this is the one I saw where they say it really gave them a boost.
All right. Yeah. So it says there it was used in the previous feedback competition in the winning one.
Yeah. And you can see, the orange line he talks about, and look at that versus look at this. And you can see here too. Yeah, that's this is the one I saw too. Thanks, Mike.
Mm-hmm.
So yes, now, but unfortunately, as Mike also pointed out, there isn't a code for that. So maybe I'll search in the prior competition to see whether anybody shared code of how they used it in the prior one. Okay, cool. So I think based on today's discussion, we'll probably jump into the next one just to kind of preserve our knowledge, although we may be all a lot more humble after doing not that great in the final one, but hey, we are here to learn, so we'll give it a crack. Okay, folks, looking forward to next week. Thanks for joining. And as I mentioned, if anything else you see interesting and or relevant and code for the same, or want to explain any of these, and maybe even Abhishek's notebook in better explanation than what I was able to provide with more detail. Feel free to jump in next week. And given what we discussed, we'd probably make the call to just continue with the third revision of this competition as our next competition. Then.
Okay, cool.
Sounds good. Thanks, everybody.
Cheers.
Thanks. Bye.
See you later. Bye.
See you all next
Thanks,
week.
everyone.